So today we're going to be graphing absolute value functions, but before we get into the new stuff, I do want you to pull out your worksheet from yesterday, 2-3, where we were putting quadratics from standard form to vertex form by completing the square. Now we're going to do problem number 8 together. So looking at this one, number 8, we have y is equal to x plus 5 times x plus 4. So what we're going to do is we're going to actually have to multiply this one out, and then we can go through and complete the square. So we do x times x, which is x squared. And then we have x times positive 4, which is positive 4x. And then we distribute 5 through, so 5 times x is positive 5x. And then positive 5 times 4 is positive 20. Then from here, we'll combine like terms and write it in standard form. X squared plus 9x plus 20. Now look at this. Before we can complete the square, we have to make sure it's in standard form and set equal to 0. Now looking at this, it is in standard form. It's set equal to 0. So your next very important step is to make sure that your a value, which is in front of x squared, is positive 1. And it is. So we can continue to complete the square. This is where you take your b value off to the side, you'll divide it by 2, and it's all that squared. Now if you take 9 divided by 2, it's a decimal. So let's keep it as a fraction, but you will want to type that into your calculator, 9 divided by 2 squared, and then I want you to actually calculate it and then put it back into a fraction. So if you do that, you're going to get 81 over 4. All right, so that's our square. Now that's what we're inserting into our equation in the correct spot. Now remember, that's what you're inserting after bx. So we're going to add our fancy 0. So we have x squared plus 9x, and then we're going to add our square. So plus 81 fourths. Now if you add 81 fourths, you've got to subtract 81 fourths so that we're really just adding a fancy 0. Otherwise, we'd be changing the problem. And then we still have our plus 20. All right, which is equal to 0. So then from here, remember, the steps are the same. You group the first 3 terms and you factor it. Now remember, there's a little trick. You won't even have to know how to factor. You can look back to what was inside the parentheses before you squared it. It was positive 9/2. So this is going to become x, and since it was positive 9/2, we'll have plus 9/2 squared. So we know our little trick tells us we can do this really quickly. And then we're going to add up this piece, negative 81 fourths plus 20. You would type that into your calculator, and you would get a decimal, negative 81 fourths plus 20. You'll get a decimal, change it back into a fraction, and you get negative 1/4, so minus 1/4. So we're done. This is now in vertex form. So our final answer would be y is equal to x plus 9/2 squared, and then minus 1/4. It's now from standard form to vertex form. So that one's done. And then for problems 9, 10, 11, and 12, I'm looking at them, like look at number 9. You're going to get it in the form y equals some function involving x. So you're just going to isolate y all by itself. And once you've isolated y all by itself, check to see if it's already in standard form. If it is, then you're done. Like on number 9, you're just going to multiply both sides by 2 to get y alone, and then you'll subtract 4 from both sides, and then it'll be in standard form. Also, it will be in vertex form, so you won't even have to complete the square on number 9. But on number 10, you're going to have to get y all by itself. So you'll have to get y all by itself, so I would subtract 6x squared over to the other side. I would subtract 12x to the other side, and I would subtract 13 over to the other side. And then you can go ahead and complete the square just like we have with our other problems. Now just make sure it's in standard form and that it's set equal to 0. And then the very most important thing is to make sure your a value is positive 1. If it's not, you've got to factor it out and then solve for x. And then factor it out and then solve for what's inside the parentheses, and then go through and complete the square. So we did tons of examples like that yesterday. So now we're going to go ahead and learn the new stuff. All right, absolute value graphs have this form. Y is equal to A times by the absolute value. These straight lines are absolute value signs. The absolute value of x minus h plus k. Now we've shifted rational functions, and we know that anything added with our x is going to be shift left and right. We also know that with quadratics, anything added with our x, what's inside the parentheses, will be our shift left and right. This is also true for absolute values. So this is our shift left and right, x minus h. Now you always go the opposite with this, just like with any other function. Then this plus k out here, this will be our shift up and down. And does our sign stay the same or go opposite? Well, just like with any other function, whatever's added on the outside of the parentheses, on the outside of the absolute values, or not under the fraction, we know that the sign will stay the same with this. Now, the major difference in absolute value functions is our a. So this a in front isn't an acceleration in absolute values. It's actually a slope. So now slopes are graphed rise over run. So you'll take the rise over the run and you'll graph it. After you've decided where it shifts, then you'll graph the slope. So you'll do the rise over the run. So this is very different than a quadratic, where quadratics have the 1, 3, 5 pattern. That's not true for absolute values. Absolute values have a slope. That a value is the slope. So you'll find your shift left and right, going the opposite of the sign. Then you'll find your shift up and down, where your sign will stay the same. And then you will then graph the slope, rise over run. All right, so we're going to graph the parent function of absolute values. Now remember, parent function means the most basic non-shifted function. So with this, absolute values, notice we have no shift left and right, and then we have no shift up and down, because there's nothing added inside the absolute value signs, and there's nothing added to the outside. So we're just going to start at the origin here. So I'm drawing in my origin. Now our slope on this one, our slope is positive 1. You look in front of the absolute value signs, and that's positive 1. So our slope is 1. So now we know that slope is rise over run. So really what we have is 1 over 1. That's the exact same thing as 1. So I'm going to look at it as 1 over 1 so that I can graph my slope. So we'll do rise over run. So then from that starting point, we're going to go up 1 over 1, 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 continuing, up 1 over 1, up 1 over 1. That's going to continue on the other side too, up 1 over 1, up 1 over 1, up 1 over 1, and so on. So notice absolute value graphs are sharp V's. So now we'll connect those. Absolute value graphs are sharp V's. So all of your absolute value graphs are going to have sharp V's looks to them. Now it might depend on if they're flipped upside down or not, depending on that A value. We'll just practice a few of these, but the very first thing you're going to do is identify the shift left and right and the shift up and down. And then you're just going to graph the slope, rise over run. All right, so looking at our first example here, we know that we have f of x is equal to 2 times the absolute value of x minus 3 plus 2. So the first thing we do is identify our shift left and right. So inside the absolute values, this is our shift left and right. We always go the opposite of the sign. So we're going to be going right 3. Then we look at our shift up and down. We're going to look at what's added on the outside of the absolute values, and the sign stays the same. So we'll be going up 2. So let's go ahead and plot our starting point. I'm going right 3 and up 2. So it's going to be right there. So then from there, you're going to look at your A value. Our A value in this one is 2. Now remember, this not an acceleration. Absolute values are slopes. So we'll have the rise over the run. Now remember that 2 is the same thing as 2 over 1. So our rise is going to be 2, our run is going to be 1. So from our starting point, we're going to rise up 1, 2, and go over 1. You'll do that on both sides. So I'm also going to go up 2 over 1 this way. Once again, from that green point, I'm going to rise 1, 2 over 1. And once again, I'm going to do that here. Rise 1, 2 over 1. I'll keep doing that. Rise 1, 2 over 1. Rise 1, 2 over 1. So over here, I'll continue over here on the right. Rise 1, 2 over 1. Rise 1, 2 over 1. So then I have my sharp V here, and I'm able to graph it. All right, let's do another one. All right, looking at this one. First step, identify your shift. Where are we shifting left and right? Is there anything added inside the absolute value signs on this one? No. So we have no shift left and right. Now we look at the outside. What's our shift up and down? So on the outside, we know that we go with the sign. So we're going to be going down 3. So down 3. So from the origin, we're going no shift left and right, but we are going down 1, 2, and 3. So my starting point is going to be right there. And the next thing is to look at your A value. That's in front of the absolute value signs. Now look, there is a 1 in front. So we know that we have a 1, and it's positive 1. So we know that it's a slope, so we'll be doing rise over run. Well, remember that 1 is the same thing as 1 over 1. So our rise is going to be 1, our run is going to be 1. So then from that point, we're going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and continuing that, up 1 over 1, up 1 over 1, and continuing that. Now I'm going to do it on the other side, up 1 over 1. These are sharp V's, you got to do both sides. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and continuing. Then we'll draw in our sharp V here. All right, we're almost done. Stay with me. All right, looking at this one, the first thing we do is identify our shift left and right. We always go the opposite of the sign. So we're going to be going left, left, 5. Now we're going to see what's our shift up and down. And anything on the outside, our sign stays the same. So we'll be going down 4. So then from here, you're going to start at the origin, go left 5, and down 4. So it looks like we're going to be right here. Now that we've plotted our starting point, our shifted starting point, we're going to graph our A value. Now remember, these are slopes. We'll look in front of my absolute values here. The value I have in front is actually a -1. All right, now remember, we do rise over run. That's how we do slopes. So rise over run. And -1 can be written as -1 over 1. So we're going to be going rise over run. Now because our rise is -1, we're going to be going down 1 and then over 1. Now once again, because our rise was negative, we're going to be going down. So then down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And then same thing on the other side. We know absolute value graphs are sharp V's, so down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Here's our sharp V. All right, let's do one more, and then I'm going to let you work the rest of the time. All right, so looking at this one, our first thing is to identify our shift left or right. Now we always go the opposite of what's inside the absolute values, what's added with what is inside the absolute values. So opposite of +3 would be left 3. So we're going to be shifting left 3. Now identify your shift up and down. Well, notice there's nothing out here adding up and down. So we have no shift up and down. So I'm going to plot my starting point. I'm going left 3, so that means back 3. And there's my starting point because we're not shifting it all up and down. There was nothing added on the outside of the absolute value signs. So then our next step is to plot A. Now remember, Our A value is -3/2, and we know that these are slopes with absolute values, so rise over run. So with this one, you'll always put the negative with the number on top. So we're going to have a rise of -3 over a run of 2. So from our starting point, I'm going to go down 3 because our rise is -3. So down 1, 2, 3, and then we're going to go over 2, over 1, 2. Once again, I'm going to go down 3, down 1, 2, 3, and over 1, 2. And again, down 1, 2, 3, over 1, 2. I'm going to do that on the other side. So down 1, 2, 3, over 1, 2. Down 1, 2, 1, 2, 3, over 1, 2. Down 1, 2, 3, over 1, 2. And now we have our sharp V. All right. And we connect it. So once again, just pay attention to the little details, because in front, if it's a negative, it's going to be flipped upside down because your rise is going to be negative. And then if it's not, though, you're going to it's not going to be flipped upside down. If this wasn't negative in front, we would be going up 3 over 2. So just pay attention. Keep these as slope, rise over run, and it shouldn't be too bad. All right, go ahead and finish that worksheet. The key is available to you, so make sure you check your answers.